This is what has been happening. Before, let's say, we use our ITS and we see that it's not informative because it's almost the same. Then we've shifted to those protein genes. We've seen that those are somehow more informative. Because in here, we cannot use sequence variation to identify them, because you might have only one or two base pair difference and it does not really demarcate those groups. So then what you can do is, whenever you go ahead with your protein genes now, you're generating plates or maybe subclade within one big plate. Let's say this is one plate, plate A. And then I've got maybe subclade A1, then here you have another group, subclade A2, then you have another one in here, A3. So, under some circumstances, what I will do is, because I cannot use my morphology, they are almost identical, I will leave my morphology aside for the time being, forget it, and come up with a system. Sometimes we can call it like a phylogenetic species concept. If the ITS doesn't work, it's still okay, because it happens sometimes. It doesn't work. So if I get something like this now, and my morphology is the same, does that mean that I can't write a good discussion? There should be ways by which I can write a good discussion. Now you have to think in a different taxonomic perspective. Look at the morph. Check in here, you've got plate A. Let's say you have 100% bootstrap support in here. Okay? Then you start characterizing. You can say, okay, A subclade A1, A2, A3. Because you cannot use morphology in here, they are the same. Then I start working on my DNA sequences. You can come up with maybe concept of phylogroups. Phylogroups. Let's say these are maybe from Chile. This is, let's say, from tomato. This is, let's say, from tobacco. Tobacco, yes. Good. So now, what is happening now? You're trying to vision or unravel different types of relationship. You say, okay, this now is characterized by specific sequences. These one have got specific sequences in here. This one have got this one. And usually, whenever you check your alignment, as I explained before, you will see your alignment that you have is a reflection of the tree that you have. Just check it properly. You will see you have this set of alignment, this set of alignment, and then it reflects on the tree. So now, nobody forbids you to come up with a new taxonomic framework in order to distinguish those species. You can also propose, if somebody wants to maybe design primers to target those specific, this could be pathotypes or pathobars if you want to, if you're talking about pathogens. Okay? So then you establish something like this, you check whether they are all specific. If not, then possibly you can have chili here as well, tomato here as well. Then still, it tells you maybe my host specialization does not work in here, but what will work is your DNA sequence data. So then what you do is you try to identify how these clades, for example in here, are characterized by a specific set of sequences. So this will form your major backbone for your discussion. I mean, this is just an idea that I can think of, but if you have worked on your species properly, if you check all these, then you should be able to come up with new ideas as well. So we've talked about this, but you can also talk about the phylogenetic reliability of the ITS, of the beta-tubulin, of the TEF, or any of the genes that you're using. So then people will get an idea. If plant pathologists tomorrow are interested in retrieving your sequences and designing specific primers to target specific pathogens or specific strain, they can do it very easily. So this is like something that maybe you can think of if you want to discuss your findings. So it depends. Okay? Does it clarify?